there, my name is Dr. Marissa May. In this video, we're going to take a look at number bases. This is probably one of my most requested video lessons because I think there's a lot of confusion with number bases, and we're going to try to give you lots of examples so it'll clear up that confusion. So a number base is just a method for writing down numbers. You have to understand that in the American system, education system, you are taught a base 10 or a decimal based system. From beginning, you'll remember that when you learned place value, you learned the ones place, the tens place, the hundreds place. Those are based on values of 10. Not all other number bases are based on 10. Let's take a look. In order to understand other number systems, it's best if we look at our own system first through a new lens. I want you to see the chart that I have here on the screen because I need you to see that this increases by powers of 10 as you move to the left. I also want to fix your attention on the decimal notation for each of the place values. Notice that the power on 10 increases by 1 as we move to the left. That pattern is going to stay the same when we move to other bases. Notice also that in order to get the value here of 6, we take 6 times its place value, 10 to the 0, which is 1, to get 6. Then we take 3 and multiply by its place value, 10 to the 1st, to get its value of 30. Again, this is going to be important when we move to other number-based systems, but it's easier to show it to you in our system, the system you're most familiar with, before we jump to other systems. All right, are you ready? Let's take a look at another system then. Let's first focus on the binary system. It's going to be probably the easiest for us because there's only 2 digits, ones and zeros. The binary system is a base 2 system, and it's most used with computers. You probably heard of the on-off switch. So like ones mean on and zeros mean off. And so when you look at a base 2 system number, you're going to only see ones and zeros. So I have a chart that helps me with the base 2 system. I want you to focus on the exponents. I did this very similar to what we saw with our base 10 system. I increased the exponents by 1 as you move to the left. Now, just to make this a little easier, I also went by and converted that to what number is that. So 2 to the first being 2, 2 to the second being 4, and you can see those in blue. So that when I put my number in here, I'm going to now take the number, the digit, and multiply by its place value to get its value. So this 1 right here gets multiplied by 16 so that we have 16. Okay. Then my 0 gets multiplied by 8 and I get 0. My 1 gets multiplied by 4 and I get a 4. My 1 gets multiplied by 2 and I get a 2. And my 0 gets multiplied by 1 and I get 0. Now, if I add all of these together, I get my base 10 number. So this number in base 10 would be 22. Interesting. All right, let me move my video so we can use the chart for the second example I have here. All right, let's look at that second example then. I'm going from base 10. That's the numbers we know, 34 to base 2. Now, when I'm going from base 10 to base 2, then I want to fill the chart as much as I can. So you want to ask yourself, start on the furthest left and ask yourself, can I get a group of 32 out of this? Out of 34? Yes, I can get one group of 32. Now, if I have 34 and I take one group of 32 out, then I have 2 left over. So can I get a group of 16 out of 2? No. Can I get a group of 8 out of 2? No. Can I get a group of 4 out of 2? No. Can I get a group of 2 out of 2? Yes, I can get one group. Okay, so one group of 2 would leave me with nothing. So I don't have anything for that last place value except a 0. So this is 34 in base 2. 1, 0, 0, 0, 1, 0, and that is in base 2. Okay, so I'm showing you both ways of taking a number that's in that base and going to base 10, taking a number in base 10 and going to that base. Let's take a look at another base so you can see the same pattern happen. All right, the hexadecimal system. You may be thinking, like, why in the world would we choose to have a base 16 system? Well, it's pretty simple to think about, is that when we do a base 16 system, the numbers are a lot shorter. They don't have as many digits. And so I want you to know, in this system, we use the digits 0 through 9 and the letters A through F. So when we count, we go 0 to 9, and then A is 10, B is 11, C is 12, D is 13. You get the idea, okay? And this system, the hexadecimal system, is used a lot for colors on web pages. So it's not abnormal for their code to be AAF, and that would be for a specific code and color. All right, so let's do the same. We're going to go from a hexadecimal system to a base 10. Then we'll go from a base 10 to a hexadecimal. So let's start with what we have. We have 4F2. I want you to notice that I put the exponents again. Started with 16 to the 0. Then I increased the exponents as I moved to the left. In the blue, I went ahead and converted that to a base 10 number. So 16 to the 0 is 1. 16 to the first is 16. 16 to the second is 256. Okay? So when we pull these out, we're going to have 4 groups of 256. So 4 groups of 256. That is 1,024. Okay? Now watch this one. That's F groups of 16. Now you have to go back to where we counted. F means 15. Count through them. F is 15. So we have 15 groups of 16, which means we have 240. Okay, and then finally we have 2 groups of 1, which is just 2. And we add these together, we'll get 6, 6, 2, 1. So we get 1,266 as our answer in base 10. Okay, so remember, the letters actually represent a number in your hexadecimal system. So focus in on how we count when you need to translate those to what number they represent. And then also think about how, you're having 4 groups of that place value, so you're having to multiply. Okay, let me clear the board and we'll go the other direction from base 10 to a hexadecimal. All right, so when we have 500 in base 10, we have to fill the chart from the left. So start asking yourself, do I have a group of 256? The answer is yes, I do. So if I have 500 and I take a group of 256 out, I'm going to have 244 left. Think about that, 244 left. All right, now how many groups of 16 do I have in 244? I have 15 of them. So I want you to think about what digit or letter means 15 in hexadecimal. The F. Good. Yes, it's always a capital. So that's 240. 15 groups of 16 is 240. So I have 4 left over. So I have 4 groups of 1 to go in this last placeholder. So my hexadecimal equivalent would be 1F4, and that's in hexadecimal notation or number system. Okay, so I think the charts are key here. I hope that when you're converting that you'll use them to go between and think about filling those groups in each column. All right, let's talk a little bit about other number-based systems. The next one we're going to look at is the Mayan number system. And you may be thinking like, wow, we are going way back. Yes, the Mayans were the first ones to use the 0. And their number system is built on bars and dots. So something to know about the Mayan system is that a bar represents 5, while a dot represents 1, and we're working in a base 20 system. Base 20. Yes, that's right. The shell represents 0. They were the first ones to use the concept of 0. So this shell you see right here means that we have 0 in that place value. The other thing that's unique about the Mayans is they represented their place values vertically, so that you notice the place values start at the bottom and go up, whereas ours start on the right and go left in base 10. So let's see if we can decipher this number in the Mayan number system. I'm going to start at the bottom. So remember, this is our first digit. Bars are 5, dots are 3. So this means we have 1 bar, which is 5, plus 3 dots, which is 3. So we get 8. So we have 8 groups of 1. Let that sink in. Before we look at the next group, our next place value has 3 bars and 2 dots. 3 bars, each being 5, that's 15, plus 2 dots gives us 17. That means we have 17 groups of 20. Think about the place values. We increase the exponents by 1. We already talked about the shell being 0, so we have 0 groups of 400. And then we have this last place value, 2 bars, 4 dots. 2 bars being 5 each is 10, plus 4 dots is 14. So we have 14 groups of 8,000. So now that we've translated from the symbols to numbers, now we've got to pull them out of their place values so we can understand what base 10 number this is. Okay, so we're going to take the digit and multiply by the place value. So this is going to be 14 times 8,000. And that gives me 112,000. Okay. Then we'll do the digit times the place value. So I've got 0 times 400, which is 0. Next, we do the digit, which is 17, times the place value, which is 20. So I've got 17 times 20. That will be 340. And then finally, I've got the digit times the place value. So that's 1 times 8. And that gives me 8. Now, if you add all of those together, you'll get 112,348. And that is this number in the base 10 system. So remember, the Mayans, first to use 0, they've got bars and dots. Bars have 5, dots have 0. But you have to think about they did their number system from the bottom to the top. So it's all vertical. But other than that, which are some major differences, but other than that, their system follows the same exponent rules, but with a base 20 cents system. All right, friends, thanks so much for your watching the lesson here. I hope this helps clears up your number-based systems. I know there can be a lot of confusion, but I'm hoping that in this lesson, I pointed out the process of the place values with the exponents to simplify it for you. I would love to hear from you. If you have questions, you want to see more videos on this topic, let me know down in the comments. Bye for now.